This is a really good question to show you how powerful the arithmetize strategy is if we truly understand it and know how to use it. That takes practice, but hopefully this video can really just like kick it up a notch for you. So the way I would know to arithmetize here is I'm being asked very hypothetically about this equation and about these radio towers, right? The intensity is 16 times, the intensity of A is 16 times the intensity measured by observer B. So, okay, well, I have no numbers there, right? I'd prefer to have actual values for the intensity. So that way I can say, okay, this, 32 is 16 times greater than 2, right? Something like that. So that's already a first clue that like they're comparing things that exist in the world, but there's no actual measurement. So it would be better if I had the values so that I could understand it more clearly. Now the other thing too though is that the distance must be changing, but they're saying it's the same signal. So that means this value P is constant between the two. So when I plug in here, when I arithmetize, I would prefer to keep P, or I would need to keep P constant, but I also notice that it's going to be very difficult to solve for R if I've got this annoying 4 pi here. So here's what I do. I assume the easiest thing. That's what arithmetize is all about, right? If we have to pick numbers, let's pick the laziest numbers. So when I do this, the first thing I do is I make P equal to the very lazy number 4 pi. 4 pi? Why is that lazy? Well, I have a calculator, so I could deal with all the weirdness of the 4 pi, but if I think about how fractions work, it would be really convenient if I had 4 pi over 4 pi r squared. Now, normally 4 pi is a really messy number, but in this case, if the power was 4 pi, then the 4 pi's would just cancel out. And then the equation I'm really working with is just I is equal to 1 over r squared. That's much easier to work with. So I would really prefer to just get rid of the complexity of this equation very quickly. So that's arithmetize at its best, right? Is we're not even just picking the random numbers because we like zeros or ones. Here we're picking the numbers very strategically because we kind of see what's coming. And we don't want this weird extra thing to be there getting in the way. Again, we could have picked any value for P because we have a calculator for this question, so pi doesn't really bother us too much, but why deal with it at all if we can avoid it? Now the rest of the arithmetize is pretty straightforward, right? The observer A measures its intensity to be 16 times the intensity measured by observer B. So let's just do the simplest thing here. Let's say A has an I value of 16 and B has an I value of 1, right? So let's make sure that makes sense with the sentence. The intensity for A, 16, is 16 times the intensity of B, which is 1. So 16 is 16 times 1. That's just a true mathematical statement. So I've picked very simple numbers here to understand now what's going to happen to the R values. So if I take observer A and put in 16 for I have now, because I got rid of the P and the 4 pi, 1 over R squared. We'll just solve, right? So we would multiply both sides by R squared to get rid of the fraction. So we'd have 16R squared is equal to 1, and then let's divide by 16. So that's R squared is equal to 1/16. And then take the square root of both sides. We get R is equal to, hopefully you know this, 1/4, but if not, again, you got that calculator. So that's leading us towards choice A. Now, technically, I do still need to finish the job here with B and just make sure that the relationship is 1/4 or 1/4, because I don't know the actual value of the radius at B yet. I mean, I kind of do because I know what numbers I picked, but if we plug that in, if we put 1 in for the I here and have 1 over R squared, we can very quickly see, oh, well, yeah, in this case, R squared is 1, so R is 1. So now when they ask for the distance, the relationship between the distances, yes, it's convenient that one of them is 1/4, and that's an answer choice, but it's not really just that the fact that A is 1/4. It's that the relationship between A and B is 1/4, right? So they're always asking for the comparison here. If we had picked different numbers, we wouldn't have this convenient thing happen at the end. We would have something annoying that we would need to then convert and see, oh, what's the relationship? So let me just show you how it would work. The distance of observer A from the radio antenna is what fraction of the distance of observer B from the radio antenna. So if we did that, we would say, okay, A over B is our actual answer. So we would just, if we use different numbers, we would put whatever we got for A over whatever we got for B, the radiuses, and then we would simplify that fraction. And we could do that with the calculator, we could do that in our heads. In this case, it's really easy to do in our heads because 1/4 over 1 is 1/4. So that's why these two numbers are the same, because we picked a situation where the radius became 1. But that shouldn't matter if we're doing it right. You'll eventually kind of get to this right answer anyway, no matter which numbers you pick. But that's kind of the moral of the story with this question is all along, because I'm so confident with arithmetizing, I wasn't picking random numbers. I could have, but I was picking smart numbers, lazy numbers, numbers that I kind of knew were going to create good situations for me down the road. 0 and 1 very often do just that. And that's kind of why I picked the number 1 for B. That was maybe a much more traditional choice. But the 4 pi for P, that was really smart because I saw that 4 pi was going to just kind of confuse things for no reason. So might as well find a way to get rid of it. Arithmetize conveniently let me get rid of it. And then A, the 16, that was just following the instructions in the question. So a lot of the aspects of arithmetize show up in this one question. 0s and 1s being helpful, picking smart numbers to make things convenient being helpful, and then sometimes we can't pick a random number because the question is telling us an instruction that we must follow. And so we followed the instruction, but it was based on our other numbers. Really good arithmetize question. Definitely with these ones that are comparing things in a formula, asking for relationships, arithmetize can help us see a relationship instead of just relying on our instincts and logic because we know that the SAT is out to get us with those things. So that's not reliable. Use numbers. Those are reliable.